Question 9, lots of photocopiers in this building. They're all talking about a week, so we haven't got to worry about the time periods like last time. But the ground floor one breaks down on average 0.4 times per week. The first floor one breaks down on average 0.2 times a week. That one's better, isn't it? And the second floor one breaks down on average 0.8 times per week. Find the probability that each one breaks down once. So this is the probability that G equals 1 and F equals 1 and S equals 1. We want them all to happen. So this is G equals 1 times by F equals 1 times by S equals 1. We want them all to break down once. So we'll work out each of those probabilities. I'll do those while the video is paused, and then we can have a look later. So I just paused while I figured out all those numbers there, and now we're going to multiply them all together, and I've done that as well. So that gives me 0.0158. So we want all of those things to happen, so not lots of multiplying. I like part B. There's a couple of ways you can do part B. It says we don't want we want at least one photocopier breaks down. So one way of thinking about this is that the only thing we don't want is for them all to be good. So we could actually find out the probability that G equals 0 and F equals 0 and S equals 0. So that's the probability that there's absolutely no breakdowns, and do the opposite of it. One, take away that, because then at least one photocopier will break down. But maybe the quickest way is to actually just do the total. The total number of breakdowns is a Poisson with a mean of 1.4, and we want the probability that at least one, so T will be greater than or equal to 1 with the 1.4 in there, and that's a quicker way of doing it, and that gives you 0.7534. And the good thing about doing that then is that you could do in part C as well. There'll be a total of 2 breakdowns, and so we can then just do our total of 2. Let's do that one. So a total of 2 with a mean of 1.4, and that gives me 0.2422417, I think it is. So different ways of doing that. Of course, we have assumed that these are all independent. Now, if they're all in the same building and the building has one massive power cut, clearly they're not going to be breaking down independently. We have assumed that they are independent.